My name is Chris Marget. I'm a product manager at Juniper Networks. I've been on that side of the table at 15 different Tech Field Day events, so I'm really excited for you guys. I know you're in for a great few days. I'm more excited for me. This is my first time presenting, so I'm really happy to be here and talk to you about automating your data center as if you were automating the cloud and how Juniper can make that experience pretty much the same. In Juniper, I work for the Cloud Ready Data Center group, and that's something we really believe, and I want to make that seem real, and I want you guys to believe it too. So that's what we're going to do. So when you're automating public cloud, you pick a cloud provider. There's a whole bunch of services there that you're going to consume. Cloud provider has an orchestration tool you can use. It's one-stop shopping. Everything fits together perfectly. Easy peasy. You could also make it two-stop shopping and use a third-party orchestrator. And that's the strategy we're going to use today. We're using Terraform. On-prem, you're not using all those AWS services anymore. Probably you've got a security box of some kind. You've probably got a secret archive vault type solution. You've probably got a load balancer, a DNS box or service, something to run compute. All those things have APIs. They probably all have Terraform providers. Most of the work you can do. But the analog for the VPC service in a data center is a completely different story. It's hard. To do an any VLAN anywhere kind of situation in your data center fabric at anything remotely approaching scale, you need EVPN VXLAN. And that is a specialist network department. You need people to do that. It's hard. But we can make it easy. So Apstra can drop right into your cloud-style deployments in your on-premises data center, orchestrate whatever's going on with a real switching fabric, and deliver the kinds of things that you do in the network in public cloud right there in your on-prem data center. So we're going to do a demo. It's an application deployment. We're going to stand up a load balancer and some web servers and publish a service. This is not an impressive demo in public cloud. It's a piece of cake. If you don't ignore the plumbing, doing the same thing on-prem is a different story, right? There's, choosing VLAN numbers. There's doing IPAM, getting the plumbing across the fabric to all the right switches, lighting up the correct ports on, physical servers, right? None of those are things you have to worry about in public cloud. It's all just transparent or invisible, and it just happens. But doing it in a real facility is a completely different story. So we've got a lab ready to go. There's a bunch of things in the lab, and I want to level set about what we've got in there so you understand what's really happening. So to begin, we've got a pile of Juniper QFX switches. They're completely unconfigured. We've also got some servers. Linux and Docker is pre-installed on them, but other than that, they're not configured. I've pre-fetched some container images, so we don't have to wait. All that stuff is cabled together in a topology like this. Got spine switches, leaf switches, servers attached to leaf switches. But this is not a running fabric. In addition, we've got an out-of-band management network. All of this equipment is attached so that we can log into it and manage it. And finally, Apstra is here. Apstra is also attached to that out-of-band network, and so Apstra is going to be one of the things that is doing work for us in the fabric today. Before we can deploy our application, we actually need to take this pile of gear and make it into a usable fabric, right? That means lighting up the ports where the switches interconnect to each other, lighting up BGP relationships between the nodes. We're going to instantiate the load balancer that we'll be using later because having a load balancer existing feels like a day zero task. That load balancer will be on a new services network, that kind of thing. So let's just go ahead and do that. This is the front page of Apstra when it is unconfigured. There are no, a blueprint in Apstra is like a running environment. We have no blueprints. If I click on the blueprints thing here, there's none. We've got a create button. We could specify some details that we want, but we're not going to do that. So we need to tell Apstra, this is what our racks look like. How many switches are in each rack? This is sort of the model of switch that we have. These are how many links between the spines and the leaf we're going to have. How many spine switches are we going to use? What models are they? which serial number has which role in the fabric, stuff like that. And rather than doing that by clicking here, we're going to do that by running Terraform apply. And so Terraform wants to create 34 things. We'll let that go. And if we pop back into Apstra here, we'll see like a rack definition called the CFD18 rack has appeared. It's a real simple rack that only has a single switch in it and nothing else at this time. We've got a template. That's another one of our design building blocks that specifies how many instances of that type of rack do we have. There's 3 of them. There's 2 spine switches interconnecting them all. And if we look at managed devices, the managed devices page in Apstra is the switches that Apstra has taken control of and is makes them available for use. And you see we've got 5 QFX switches here, or I guess they're EXs. And they're all green lights. They're under management now. So Apstra has taken charge of all that stuff. Oh, and it just changed. I don't know if you noticed in the blueprint column here, these switches went from available for use to assigned to use. So these are assigned to the CFD18 blueprint, which if we go back to the blueprints page, we had none a moment ago, and now we've got a blueprint defined. You'll see Apstra shows there are some anomalies, 6 anomalies right now. One of the validation things that goes on in Apstra is Apstra knows that all these links are supposed to exist, that all these BGP relationships are supposed to exist. And independent of pushing config, Apstra is constantly revalidating that all of the things that are supposed to be happening are happening. And that runs in a polling cycle. It'll take a few minutes, and you see the anomalies have reduced to 3. So Apstra's noticed that 3 of the problems have just gone away, and a few remain. Okay, so we'll pop into there.
So Chris, just so I understand what's happening there, because
thank you for interrupting me.
We're cloud people, so you have to help me understand. When you say Apstra understands there's supposed to be BGP relationships, what does that mean exactly?
In public cloud, you don't have to worry about how a packet gets across the cloud provider's fabric from one end to the other, right? It's not your problem.
Mm-hmm.
Right? It shows up on your VNIC within the hypervisor, and how it got from one hypervisor to another, who cares, right? But there's switches under there, and somebody had to configure them, right? And the same thing would be true in your data center, right? There's switches that need, possibly thousands of lines of configuration to make this all work. And so those thousands of lines of config just got pushed into those switches. And some of those configuration elements said, you are a leaf switch. There's a spine switch above you. You should, there should be green lights on that port. And you should have a BGP relationship with that spine where you're learning routes to other leafs and all of those kind of things. So since Apstra knew what to expect, because we defined a topology with leafs and spines below, or spines and leafs below them and so forth, Apstra's checking that all of those things are the way they're supposed to be. So that was the intent validation stuff.
And if I'm standing up existing services, so if this is not networking, if I'm comparing this to a different type of service I'm standing up, if there's a state that needs to be, after I start up the server or instance, and a application needs to connect to a database, let's say, once I start up the server, that service, that's not instant. That has to happen. So Apstra, in a sense, is checking to see if that state is expected.
If you had an orchestrator that made, a web front end and a database and expected them to be able to reach each other and talk, and that orchestrator had a subsequent pass that made sure that the front end was actually logged into the database and doing transactions, that would be a good analog for what we're doing.
So if we went back to anomalies now, there should be.
Yeah, I think there's an anomalies view on there. Well, things would be red or yellow across the top, and they're not. It would be on the active tab there. So since the active tab is all green, the anomalies have all evaporated.
I'm sorry, I've got another question. You started this conversation with a focus on cloud style network operation. And I'm trying to figure out what is the difference between what you're showing us here and what would be typical data center network operation.
You didn't see me open a command shell and type, platform specific, JNCIE or CCIE switch incantations into any devices.
Okay.
Right. And that goes for the initial setup of the fabric that we just did, and also for subsequent operations, day 2 stuff, right? So in cloud, you either with Terraform or Pulumi or some tool or the web UI, you click the new subnet button, and that happens, right? On premises, that may be hundreds of lines on hundreds of devices that all need to be individually configured to have all the right details in them. And for a lot of you, I imagine, that means open a ticket with the network team to make that happen in a real data center, right? So that's the difference, is Apstra's web UI gives you a new subnet button. We call it a virtual network. And the Terraform provider gives you a virtual network Terraform resource. And the same kinds of things you would put in an AWS subnet definition, resource definition in Terraform, same thing here, right? You know, what VPC does it belong in? We call it a routing zone. You know, what account does it belong in? We call that a blueprint. But you know, it's the same style of stanza with the same few attributes, and it's just, you know, write your Terraform definition.
I promise. Last question for me until you get started again.
Yeah.
The one of the things that kind of you know kind of wave the magic hand over. I've done a lot of data center stuff.
Yeah.
And it's never this clean because I'll take the bullet for this one. I plugged the cable into the wrong port.
Yep.
This is kind of connecting the magic of the cloud to the magic of the actual person who racks and stacks it. How do I know what if I plug the cable into the wrong port? This presumes that all the cables are plugged into the correct port.
So when you define the rack, I didn't show you, but when you define the rack, you have to specify, you know, well, there's a switch in this rack. It's a certain model, right? I want to use the, you know, 100 gig ports on the end for my links to my spines. I want to use the 25 gig ports for the links to my servers, right? That, you know, you sort of organize your device and how you want to use it. And Apstra will then choose which interfaces should be linked to which devices. And there's a let's see, cabling for physical links. So there is a list of links of all the things that should be attached to which other things. In this case, these are Apstra's choices. We could have been prescriptive about it. And in either case, whether we're prescriptive or we let Apstra choose, when Apstra looks at the topology and finds something different than what's actually cabled, we would have anomalies. There'd be blood on the screen.
So in theory, I could be a service provider and I can have a set of pods, and these pods can be pre-cabled, and depending on my customers, my end customers who consume this at pay-as-you-go, they can stand this up and down based on that pre-cable. So I don't have to always have somebody go back in and recable something. I can tell Apstra where
there's a button in the UI that says discover the as cabled, and so long as there's a cable that meets every need, right? A link from every spine to every leaf, or you know, whatever. As long as there's a cable that's kind of in the right place, we can use it. And if it's cabled completely wrong, then we can't solve that problem. You got to go move wires. Yeah. Okay. So yeah.
So I'm going to try to be quick with two
Super.
questions. So the first one is, you've already mentioned thousands of lines of code.
Yeah.
Are we going to see the Terraform code at some point?
I mean, you won't be surprised by it. Also, I'm going to give you a link to the Git repo so you can read it.
Fantastic.
But I mean, you know, it is Terraform. It's not, you know,
yeah.
You will be bored.
There's a difference between Terraform there's a big difference between different Terraform providers, so that's why I asked the question. My second question is, you mentioned that the Apstra would be built in a place where it would have the ability to connect to the out-of-band.
Yep.
So where exactly would that VM live?
So it's up to you. You know, you could bootstrap your whole data center on your laptop, just run that VM there and then move it later. You could buy an appliance from Juniper and run it on that thing. You could, you know, a lot of enterprise environments have a small, like, critical services management cluster that's separate from the actual workload. So yeah, it's up to you. We don't take a position on it, but the Apstra VM needs to be reachable from your browser, and it needs to be able to reach the physical out-of-band management ports of all of the devices that it's managing. Okay. As far as the code goes, so the Apstra provider is out on the registry, and you know, you can look it up. So if we look at routing zone, this is our VPC. You know, you name it, you have to assign it to a blueprint, because the blueprint is the large construct that refers to the equipment, and then a VPC, which is a routing zone, lives inside one of those. There's some optional parameters here that you could include or not. So the Terraform provider is not auto-generated, by a machine and unfriendly. We've taken pains to make it as easy to consume, and this is a very knowing look, and I've been there too.
Yep.
So and I know just how unfriendly an auto-generated experience can be.
Perfect. Thank
One
you.
question about you saw sort of resources that were coming online and then were failing, and so that's always the trick. Terraform is notoriously, sorry, all of my friends at HashiCorp, bad at state management, especially with resources that have any kind of drift. So if you make a change to a live environment, your Terraform state believes that that resource isn't where it actually is now. When Terraform tries to reapply, it does naughty things like destroys resources to rebuild them because of order dependency and a misunderstanding of order. So how do you handle like dependencies and eventual consistency when resources are coming up and out of order?
So those resources, the operational state of things that takes time to happen, and the objects that you create with Terraform, like new subnet, right, are two different things, right? So the new subnet directive, you run that and it's done. It's encoded in Apstra, and making sure that actually makes its way out to all the devices is an Apstra and device problem, not a problem on the relationship between Terraform and Apstra. So that stuff is very stable and is fine. For the most part, the implicit dependency graph in Terraform works just fine on our stuff. You probably could get yourself into trouble if you really tried to. But I would say you would have to try to make that problem. There are a few cases, just like in AWS, there's like attachment type resources, right? Which those don't necessarily have a built-in dependency on the things that they're attaching to the other things. Right?
Timeouts are a weird problem especially with that stuff, where like we've got eventual consistency, but it's like they always swing. But in the data center, you just may have a consistency model it's going to take 38 seconds, versus 8 to do a resource apply, and you have to. How do we build in like timeouts and managing idiosyncrasies of the bespoke data center?
Yeah, so all of that stuff is on the other side of Apstra, and Apstra takes care of it. The Apstra API presents a consistent interface that Terraform consumes, and it's
Terraform's the plane that gets you in the parachute to the top, and then Apstra is the parachute and the fantastic trip on the way down.
A lot of those ugly problems of dealing with devices and their own timing is on the other side of this experience, and that's what Apstra's really good at.
So Chris, I don't want to kill your pace, but Gina has a question, and I wanted to make sure we get it in, whether you're going to address it as part of the demo. But blueprints, how do they actually get there? Like, where did the blueprint come from?
The blueprint is instantiated, and I'll show you in the GUI. You can see real easily by choosing a name, a couple of radio buttons for style, and then you choose off a template. So I showed you the template earlier, which said 2 spines and 3 leaves. That's it. Choose a template, instantiate, name it. That's how a blueprint comes into existence. Then we bind switches to roles in the blueprint and so forth. There were a lot of resources that were configured to make that happen, because we had to, we created the blueprint, and then that switch comes in, right? But it's normal feeling Terraform stuff, I think you'll find.
Can you do a reverse where you can actually learn a blueprint from a live environment, basically a write mem?
I haven't implemented import in any of the resources right now, but a lot of people have asked. The Terraform import feature would be a really light lift for us. But you don't get the how did this come to be context, right? This if we're going to create a VPC for every customer in the database, and so we've got a data source that does a database lookup, and then we loop over those results and make a routing zone for each one. Like, you're not going to get that out of an import, right? You're going to get text.
Yeah, I guess I'm more thinking about like a data center recovery, like a DR type of situation, like to be able to say we've adjusted a live environment. We can dump the config so that if something went sideways right now, we can immediately.
I mean, you could apply the same set of Terraform configs against a different environment, and it would just do all the same work, and it would happen quickly. Yeah.
You could go halfway, where instead of you do an import, you just actually build the Terraform code next to it, and you say, "Let me see this in Terraform," and it just spits it out, and you say, "Okay,
Yeah,
copy, paste, apply it to a different."
Since 1.15, Terraform has got a new style of import that actually writes configs for you. It's really nice. Yeah, it's very much like what you said. Okay, so we haven't looked at this blueprint yet, and we should do that. So in this blueprint, I said in the goals thing that we were going to make a routing zone, a subnet, and a VLAN. And so let's just take a quick peek at those. It's on the staged tabs. We're going to go virtual. So routing zone. There's a routing zone called CFD18. This blueprint didn't even exist, so that's obviously new. There's a single virtual network, the services network, where the load balancer lives. And if we take a close look at that thing, I prescribed this IPv4 subnet in the configuration, but I didn't choose the VLANs. So Apstra lit this up on all 3 of our switches as VLAN 3. So this is a choice Apstra made. We let it just take from the pool, and it chose the first available VLAN. And this horizontal line represents that network. It is extended to the server called S4. If we pop into S4, you'll see, no, I didn't do it that way. I did it this way. IP link list. We pop into S4. There's a Ethernet 1.3, so tag 3 on port ETH1. The VLAN chosen by Apstra is now configured as a Docker network on that server, right? So Apstra's choices and Apstra's data is seamlessly integrated with Docker running on some server, right? So we didn't know that was going to be VLAN 3 ahead of time, but on Apstra, Apstra made a choice. Docker has the data it needs now. Okay, so let's take that a little further. Exit. Probably pop back to the slides. Okay, so we made high-level API calls against Apstra. Make a, here's my leaves, here's my spines, make a routing zone, make a subnet, that kind of thing. There is not a single line of Juniper Junos configuration code in this project. So I didn't log into a switch. I didn't have canned switch configs. We didn't have to do any of that. And all of the stuff in Docker and Apstra is seamlessly coordinated, and the load balancer is up. Let's just validate that real quick. Yep, so the load balancer is here. There are no backends configured, but the load balancer is up and taking traffic. This load balancer didn't exist a minute ago. So I said we're going to do an application deploy. Now that we've got Fabric to work with, has a load balancer in it, let's do an application deploy. We're going to make a new subnet for our application servers. We're going to light that subnet up on 3 switches. We're going to extend it to 3 web servers, and we're going to instantiate some web services on there.
Chris, you said something that I have to ask a question about. You said we didn't log into anything, but normally there's some sort of authentication that has to be created somewhere in order for the Apstra to communicate.
Yep, good point.
Well,
there is, in Apstra, there's a thing called a device profile, which keeps usernames and passwords that can be applied to devices. That already existed in the running Apstra. I didn't mention it. You can't Terraform that because I don't want to encourage you to put passwords in Terraform config files. Mm-hmm. So that's something that you would manually set up a device profile for a device, and then then Apstra knows how to manage that device.
Gotcha.
But yeah, it's not Terraformable for
Can I use
safety reasons?
Can I keep those username passwords in like a vault or something like that and call that from Apstra? Or do I have to hard code those into Apstra? Cisco got into a lot of trouble about hard coding.
Yeah, so it's not hard coded, right? It's a value you control. But I think right now there may be other ways to authenticate, but the only one I'm familiar with is username and password to the switch. I do know that in Apstra that's encrypted using a per VM private key, and it's I think reasonable practices there. Okay, we're going to deploy the application. Boy, we're way behind here. Okay. So this apply is going to create what we call an IP address pool and assign it to that blueprint. The address pool is going to get used in this application deployment. So if we have a peek over here, resources, IP pools. So the CFD18 apps with 17 and 24, this pool is here. You can see it's already being used because within the blueprint, we have staged virtual networks. The services LAN we just created, the CFD LAN we just created chose a /24 from within that pool that we created. It looks like it's the first one. And that subnet, we'll see, has been extended to all 3 switches and then further extended to servers. So here's that subnet. It's on rack 1, rack 2, and rack 3, and server 1, 2, and 3 are attached to it. So we just did that, and I should not have exited that window. That's exciting. So we're logging into one of the servers here, Docker network ls. So the CFD LAN just appeared here, Docker network inspect CFD. And you see the CFD LAN on this Docker host at VLAN 4, a choice made by Apstra, IP address with 17 in it, choice made by you guys, encoded into Apstra, now appears in Docker. And if we look at our HA proxy now has container instances that it sees are up, and they've been up for 2 minutes. So this web service is up. So all these disparate things, the load balancer, Docker, Apstra, the switches, they're all sharing information. It's all coordinated by Terraform. This might feel like a Terraform ad a little bit because I'm really showing you Terraform and how great it is at coordinating things. But that's kind of the point, right? The point is the network disappears. Network becomes super easy, and we didn't have to make any phone calls or ask any favors from the network team.
How would this work with like when you get up to Kubernetes and a third-party CNI?
The network plumbing is whatever you need it to be.
Right. So
it could be an IP handoff to your Kubernetes host. It could be a VLAN. It could be routing with them. All of those things are possible.
So it's all basically you're agnostic at least.
We're just making the plumbing invisible, or making the plumbing, Terraform configurable. And for you guys, like any new service you consume in the cloud or new provider you consume, right? You open this thing up and it's, what are these resources I need to create? They're all different, right? So, we're going to be another one of those things, but this is a surmountable problem, right? You guys deal with new abstractions all the time. And we're not giving you the new abstraction of, spend a decade becoming a networking expert to make these things happen.
When we've got the fun of when you get to the app layer configurations where all the cube kids are telling us that it's layer 4 and 7 where that's where the fun is at, and ultimately when we get into service mesh, so this model
for the people that can ignore the plumbing, I congratulate them, right? That's great. Right? But for anybody running on-premises services, you can't ignore the plumbing, right? It's got to get done, and we can make that easy. So this is one of our web services. I think we had 5 of them running, and they chose a random color each. So there's 5 web servers there, load balanced by the load balancer running in server 4. Okay. Last thing I wanted to show you. So we just talked about this. We don't care about VLAN numbers or individual IP addresses and whatnot. These things are all cattle. We could be prescriptive, but we let Apstra make choices. Apstra's choices flowed out into other stuff.
I would actually like to take a question kind of for the start of it all, because for me, also as one of the cloud people, I just want to ensure that I understand the whole flow. Before we kind of do the Terraform apply that you showed from the start of your demo, how do you define? You would need to have a way to define all the different devices that Apstra would need to connect together and create a virtual VLANs from and all that. Do you do it in the racks in the Apstra UI, or is this something you also define in the Terraform provider as part of the Terraform provider configuration? Or
I lost you a little bit there, but you will need to be familiar with some Apstra concepts, the same as you'll have to learn each public cloud. And you'll find yourself writing Apstra-specific Terraform resource stanzas like this one on the screen right now. I didn't show that stuff because I didn't think it was that interesting. I figure you guys know Terraform, but it looks like this. This example, I wanted to just illustrate something many of you probably already know, that, in Terraform, we just pass data between objects, right? And in this case, I didn't specify an IPv4 subnet or IPv4 virtual gateway in this resource definition. That data still got populated. And then another resource that needs those facts, can consume it, whether or not we supplied it or not. So, passing things by reference within Terraform is, super powerful and makes these kinds of integrations seamless and flexible. Okay, so the last thing we're going to do is move the load balancer to AWS. We're going to, so this is the topology. So on the right is the fabric we've already built with a new router. It's going to do IPsec with an AWS virtual private gateway and a new subnet and load balancer and VPC on the AWS end. So on the AWS side, here's the list of resources we're going to create. On the Apstra side, we're going to create a dual homed router plugged into 2 different switches, and we'll exchange BGP routes between those environments. And if I didn't screw up my credentials a minute ago when I closed the window, let's see, I want to change the name. Since Stephen was making gallium jokes earlier, do that. Terraform apply. All right.
Go for BI. Okay. Not even Vim. You're old school. I love it.
That's a pretty old muscle memory in action there. Okay. So we don't have to watch this run, but if we look at Apstra, we can see some things happening probably. Virtual networks. So a couple of new handoff networks, Transit 1 and Transit 2. That's places to plug routers in, and they land on different switches. We've created a routing policy. Oh, it's not here yet. Wait, routing policy. Created a routing policy which allows the AWS network to be learned on the Apstra side and allows the only member of our application deployment network to be advertised up to AWS. And I haven't shown you connectivity templates before. Connectivity templates is the idea of an interconnect between a switch and something out in the world. And so here we have it, BGP peering with that router that just got created. And it looks like everything has gone green. Oh, not quite yet. Oh, we're waiting on DNS on the Amazon side. Of course we are.
For the, that's slowly coming out, which I know too well.
Yep.
The Time Voyager, I'd love to just take a peek. So I'm assuming that this is a way for you to sort of walk back.
Time Voyager is a point-in-time rollback in Apstra. There's no Terraform support for Time Voyager because, why would you want to roll back to a point in time when you can just back out a project or a resource or whatever? But Time Voyager is great for, my God, what have I done on a Friday afternoon, right? Just go back to what it was before. And it's also good for auditing and accounting kinds of things. If you have to do a forensics investigation into the state of your fabric and when and why did the thing happen, you'll have a record of all that kind of stuff. This is risky, not knowing if the oh, look at that. So a public address in AWS has come up with a load balancer, IPsec to our data center. None of these resources existed a minute ago, and we have the 5 web servers we looked at earlier in their 5 different colors. And all of these things are seamlessly integrated by Terraform, and it really makes the data center plumbing just sort of fade away for people who don't want to think about it, which I think is you guys. Yeah, I'm going to skip ahead. There's a QR code there that will bring you to the repo that did this work. Okay, thank you very much, and
thanks a lot, Chris.
My goodness, time. I'm so sorry, everyone.
Can I have a few questions, please?
Yeah. I'm going to just stand out of the way.
I don't want to interrupt your flow. So my first question would be about the provider. So I was just going through the GitHub. I can see your name. Who is maintaining it? Is it like, Apstra's commitment to sort of like maintain this?
We think it's important. The team is growing.
Okay. And is it your internal people who are maintaining it?
Yes.
Okay, great. That AWS bit, which you were showing,
yeah.
That has been done through Apstra or has been done through the Terraform?
Well, there's some Apstra side work because there's an IPsec relationship across the internet.
Yeah,
right? So,
yeah.
So there's a new router plugged into Apstra.
Okay.
Apstra has a BGP peering with that router, so it can learn routes and like configure the data center ports where the router's plugged in, that kind of stuff.
Right.
And then the rest of it is AWS VPC, Virtual Private
So
Gateway.
it's not like you're a single pane of glass for like everything. You are only maintaining it on-prem world. That's where you sort of like the API gateway for anything which runs on-prem.
I mean, it's a really strong analog for AWS VPC is what we're offering. Plus all the parts that you don't ever have to see that VPC makes magic.
Okay. Do you have any Terraform modules pre-baked?
We're working on that. There are some in some various Git repos. We've been talking about publishing them on the registry, if that was interesting. I'm not sure why that's interesting, because you can consume them just as easily from Git. But yeah, putting modules on the registry is something we're talking about.
Yeah, I think it's interesting. I mean, like, some of our clients are interested in a pre-built modules.
I mean, whether you get them from source, registry host / whatever versus source Git : whack whack, right? Either way you could get them.
Okay.
But yeah, there's a handful of things like, a BGP relationship, right, requires like 5 or 6 different resources to be integrated, and a module is a good use case for that.
All right.
Yeah. So
and
watch this space is the answer.
cool. Thank you. And then you've mentioned like intent many times, but for me, like intent is much deeper than just routing, switching, and setting the ports. Like, are there any intentions to like look a little bit further, like firewalls and et cetera? Because you showed great demo around the hypervisor and how you like orchestrated with the networking. But how about like security and firewalls?
I mean, there's already good tooling in that space that you can use and integrate with your existing automation tools.
Okay.
Right. Where there's a real lack of good tooling is vendor independent and open standards fabric configs. Right. So that's the really unique offering here. Is there's no place else that you can say, make me a subnet, and that subnet will appear across a data center fabric using standards-based, right? There's nothing magic about the Junos configs or Cisco configs or whatever, right? Everything is using standards-based EVPN, BGP, VXLAN, right? So we don't care what switches they are, and we're going to configure them, like your network admin might have, but super reliably and without typos.
And from Cisco perspective, so that's Nexus 9K you're supporting, or
a variety of platforms. There's a hardware compatibility list.
Okay. Thank you.
Okay.
I have one quick kind of like summation question, I guess. So when we first started, you had a completely blank screen, and then blueprints popped up, all those other things popped up. At least that's what it seemed like. Which came first, the chicken or the egg? But did Terraform come up, or did the blueprint come up first?
I mean, Terraform. So I had the configurations in a Git repo that I've shown you, and the Terraform's not running as a service or anything, right? It's just a command I typed on my workstation.
Sure.
So Terraform read the configs and made all those things appear in Apstra, which extended them onto the switches.
So Terraform built the blueprint?
Terraform built the blueprint.
Okay.
Terraform built the design elements that went into the blueprint, so rack definitions and object types and whatnot. Terraform instantiated the blueprints. Terraform brought switches and attached them to different positions in the blueprint. That serial number is spine 1. That serial number is spine 2, and so forth. And then, so that was our day 0 stuff. And then for day 2 stuff, we mostly did, create subnets and light up edge ports.
And you may have touched this, but just on that last piece, did Apstra make the decisions for like the BGP peering, ASN numbers, and all of those different things for you, or were those coded in?
The AWS AS number is a public registered number. I typed that one in.
Okay.
The Apstra numbers I didn't type in. But most of those things, if it's something that can be pooled, Apstra can make choices for you. Right.
Gotcha.
There's AS number pools, IP pools, VLAN pools, all of those kinds of things.
And then the last question, I swear this was last for me, but with all that discussion that we had previously around AI, is this intent, the idea that with this intent that built within Apstra, now it has that sort of, me being a Kubernetes guy, I think of it like control loops. Like it knows what needs to be there and knows how to maintain it and keep it. is Apstra going to be able to do that for us?
Yeah, those errors that we saw in the beginning, right, were because the intent that I had just expressed to Apstra was that these two leafs should be talking BGP to each other, right? They weren't yet, right? So there was a problem there, and the closed loop validation found that. So there's closed loop validation for lots and lots of details of the fabric operation, and usually when those kind of things are going to go wrong, is there's a firewall in the middle that makes it impossible, or an equipment failure, or a cable's in the wrong spot, or that kind of thing. In any other network, that validation would catch stuff like operator did it wrong.
Yeah.
Right. But our promise is we're not going to do it wrong, but we are going to catch failing devices and external problems.
And you mentioned this earlier, but I think it's worth bringing up again. Something incorrectly configured, or something that needs to be added in certain spaces, equals a ticket, equals weeks of waiting and back and forth. And this was just very quick.
Native tools for you guys to make stuff happen like you make it in the cloud, right? That's the messaging. Is this is an on-premises data center made with real plumbing equipment, real switches and stuff. But it's a little Terraform stanza to make a thing happen, and you get that service that you want right then.
Beautiful. Thank you.
Okay.
So can we keep going, or do you need to move on? Or
Well, we do need to move on,
Yep,
but
okay.
I can keep talking to you.
just it's a couple of quick ones. So I guess on that note around the compliance of the blueprint, what happens if something in the environment gets out of compliance and we've got anomalies? Do we have decisions on how to react to that? Like, can we, if Apstra can fix it, whatever it might be, can we tell it to go and try and resolve that thing, or is it just going to flag it for someone to come in and have a look at?
I think most of those things will be just flagged as anomalies that you should investigate.
Okay. Yeah. So there's no kind of automated
if there's-
remediation at this point.
I mean, I can't think of too many things that could be automatically remediated, because the things Apstra can control are device configs, and those are going to be right.
Mhm.
Right. So the problems that come up will be
It's
problems that come up because of stuff outside.
Okay. And just on the note of who are you seeing in your customer base as being, I guess, the consumers of Apstra? Like, we've got, especially in enterprises, there's still networking teams that like to manage the network and the platform itself, I guess, and the fabric. What you've shown us here is very much in our realm of being, cloud consumers and using something like Terraform. Are we coming in, we cloud people kind of coming in to just consume this from our network team, if that still exists in the enterprise, and we're managing all the Terraform, or do we want network people to get involved in the Terraform as well?
I mean, I would love it if you went home and told your network team, I need this capability, go buy that product. So yes, yeah, do that.
Yeah. I guess just from an operational perspective, is this network people still writing the Terraform and doing all of this stuff, or are they making this consumable to other people within the business and saying, hey,
There's a role-based access control situation in Apstra.
Okay.
So if you had it, your network ops team, if they were the ones in charge of it, could absolutely extend that right to you.
Yeah.
With whatever constraints are appropriate.
Okay, cool.
Yeah.